Hey guys, and welcome to your next CEGUI tutorial with C++, SDL, and OpenGL. And today we're going to be making it so that we can use a custom mouse cursor. As you can see right here, this mouse cursor is the Tazerac look mouse cursor instead of the normal default just white mouse cursor. We're also going to inject inputs, which is why the mouse is able to move around and why I can actually click on this little Hello World button here and have it flash. And we're also going to be injecting inputs in Unicode for text. So you'll learn a little bit about Unicode, and you'll also learn something about bit shifting, because I haven't taught you bit shifting yet, and we need it for this part. I should have taught it to you before, but I haven't. Sorry, you'll learn it in this video. Alright, have fun. Alright, now the first thing we want to do is start adding some stuff to our header file. I think the first thing we should work on is the mouse cursor, because that's the easiest thing to implement. So let's do that. We're going to start with a set mouse cursor function, and this is going to take for a parameter the file path. So std string, and this will be the image file. And we also want to be able to toggle on and off our mouse cursor, so we're going to add a void show mouse cursor, and we're going to add a void hide mouse cursor. Like that. Now we're going to grab these three functions and just plop them into our CPP file below the draw function, at least that's where I'm putting them, and then give ourselves some braces like we usually do. And of course we want to make sure we put this before each function. There we go. Alright, now we can actually implement these. The set mouse cursor function is actually really easy. We're pretty much just going to be loading an image file in and then setting it for our default image for our mouse cursor. So what we're going to do is we're going to say context, and then we're going to say get mouse cursor dot set default image, and we're going to just use the image file. Now if the image file doesn't exist, we'll get a crash somewhere. We could do some exception handling, but I haven't taught you guys exception handling right now, or yet, so we'll just go with this for now and not worry about it. Now for show mouse cursor, it's even easier. We just say imContext dot get mouse cursor dot show, and of course hide is the same thing, except we have hide instead of show. Now let's test this out and see if we can get a mouse cursor visible. Let's go to gameplay screen.cpp. Now here we're creating our test button. So right after we create the actual test button, let's go ahead and show ourselves, or load ourselves a mouse cursor. So we're going to say mgui dot set mouse cursor, and we're going to say, right now I'm using the Tazerac look scheme, so I'm going to say Tazerac look slash mouse arrow. Now you're going to have to go look in the data files if you're using a different look and feel, because it may not even have the mouse arrow implemented and you'll get a crash if it's not there. So just make sure you go look if you're using something else. Now we'll go ahead and show it. Now by default it is shown, but we'll just do this for completeness. And this is going to show our cursor. It's not going to disable the default cursor, so we're actually going to have two mouse cursors. Now I'm going to run it in debug mode and we'll see if we get something on the screen. It should appear somewhere. We'll take just a second here to build. I haven't built it in a while. There we go. And okay, I don't see the mouse cursor, but it is definitely there. The reason it's not shown is because we aren't injecting any input. We're not telling the game that our mouse cursor is actually moving around or telling it where it is. So that's what we need to do next. So let's go into our GUI header file again, and this is where we're actually going to start injecting some input. So what we want to do is we want to have a function that takes an STL event and then processes that event and passes it on to CEGUI, because CEGUI doesn't do its own input handling. They want to make sure you can use it with any window manager or any input manager that you have. So we're going to say void on STL event. We're going to pass STL event like that, and we're going to drag this into the CPP file and implement it. There we go. Now in the header file I am getting an error because the STL event is not declared, so we need to go ahead and do an include. Now we could include all of STL here, but it would improve compile times if we only include what we need. So let's just include STL slash STL events.h. That's what we want, and that'll get rid of this little error right here. And then in GUI.cpp, of course we forgot bingen GUI. I gotta put that there as well. Alright, now we can start implementing this function, and like we usually do, we're just going to be using a switch statement on the event to look at what the type of the event is and then process it accordingly. So we're going to say switch, and we're going to say event.type. Now inside here we're going to have a bunch of different things, and I'm going to just copy paste from Notepad just so you guys don't have to see me type it all out. I don't want to waste your time. So we have STL Mouse Motion, that's for moving the mouse of course. STL Key Down, Key Up, you're familiar with that. STL Text Input, this is for Unicode text input, which I'll talk more about later. We have SDL mouse button down and SDL mouse button up. Those are the events that we're going to be processing right now. So the first one is really easy, the mouse motion one. We're pretty much just going to be telling CEGUI where the mouse is. So what we can do is we can say mContext, and we can say inject mouse position. There's also a inject mouse motion, but we are going to be just using inject mouse position. We're just going to tell it exactly where the mouse is every time the mouse moves. So we're going to say event.motion.x and event.motion.y. Those are the two parameters, and that's all we have to do for mouse motion. Very easy. Now for STL key down and STL key up, it's a little bit harder because what it takes is if we go to mContext and we say inject key down, there we go. If we go here, I'm going to go to the function, I'm going to go to definition, and you'll see that it takes this CEGUI key scan. It takes a scan code. Now STL will also give us scan codes. However, their scan codes may be a little bit different. We're not guaranteed that they're going to be the same, and they probably aren't the same. So what we need is we need a conversion table to actually convert them so that we can take our SDL scan code, turn it into a CEGUI scan code, and then pass it into CEGUI appropriately. So to do that, what we need is a conversion table. Now luckily, CEGUI was kind enough to already give us one. I'll put a link to this, this website in the description. And we have this table right here. Now unfortunately this is for the old SDL, so we're going to need to make some modifications. It's not going to work right out of the box, but I'll show you exactly what we need to do. So I'm copying this whole thing and I'm going to paste it right above on STL event. I'm not going to make it a member function, I'm just going to have it as a little helper function. Now first, we're not returning a CEGUI uint, we're going to return a CEGUI key scan, because we're returning a scan code. And then the input here, it's not SDL key anymore, it's SDL key code. And to get SDL key code, we need to include something else at the top, I believe. No, it should be included in events. We're good then. Alright, now most of this is correct. However, as you can see here, we have some errors. For instance, these keypad ones are not found, the numpads. Numlock, scrolllock don't exist anymore. L-super, R-super. Now, I don't need this. I don't need numlock or scrolllock, and I don't need the numpad. I tried to look for the actual keypad, the new ones, but I had no idea what they were, so you guys might have to do a little bit of research on that if you actually need people to be able to use the keypads. But luckily I was able to just delete all those problems, and then it was able to work fine. Now instead of returning 0 for default down here, we're going to return key unknown, because that's when we don't know the key. And right here at the end we don't need to return 0 because all control paths here are going to return a value anyways, so there's no need for that extra return. 0 at the end, it'll never actually happen. Okay, so, and you'll notice there's a using namespace CEGUI in here. That's why you don't have to type CEGUI before everything. It's pretty nice. Alright, now that we have that, we can actually start injecting these keys. We can do the conversion very easily. So what we're going to do is we're going to call this function, which is a huge name, STL key to CEGUI key, CEGUI, oh my gosh, tongue twister. And we're going to pass in event.key.key.sim.sim. And that's all we have to do. So that's going to inject a key down, and it's going to be using the correct key code. And now for key up, we just say inject key up. Also very, very easy. And now let's skip text input right now because that is the hardest one, and let's go on to just mouse button down. For this we're going to do another conversion function, but this conversion function is actually really, really easy. So let's go ahead and start writing it. We're going to say CEGUI mouse button. That's what it's going to return. And we're going to say SDL mouse, or we'll say SDL button to CEGUI button. Nice, huge, verbose name. Now the parameter that it takes is, if we type event.button.button, if we go to the definition of this, you'll see that it is a uint8. So we're going to be passing in a uint8. We want to make sure we use the exact same type, which a uint8 could also be an unsigned char, pretty much the same exact thing. uint8 SDL button. Alright, we're going to pass that in and we're going to convert it. Now this is just going to use a big switch statement. Actually, it's not very big at all. Switch, and we're going to say SDL button. Now we have 5 different buttons that we have to worry about. Now there may be more, but these are the 5 that we care about. We're going to say button left, we're going to say button right, or button middle, then we're going to say button right, and we're going to say button X1, which is like a little extra button on some mice, button X1, and then case SDL button X2. Those are the ones we care about, and for each of these we're just going to return the appropriate CEGUI button. So we're going to return CEGUI mouse button. I can't spell anything today. GUI. When can I ever spell anything? Mouse button, left button. There we go. And I'm just going to copy this and change it for each of them. 3, 4, 5. So this is going to be right button. This is going to be, just kidding, that's middle button. This is right button. This is X1. So button X1, X1 button. There we go. And then X2 button. And if we fall out of the switch and we don't hit any of these return statements, then that means we didn't find the button that we passed in, or we just passed in a bad value. So we're just going to return, and we're going to return the mouse button, no button. There we go. And we're going to do this right. Okay, now we have another helpful little converter that's going to give us the CEGUI button from any SDL button. So what we're going to do is just use that to inject our mouse button. So we're going to say im context inject mouse button down, that one, and we're going to use our big function SDL button to CEGUI button, and we're going to pass event dot button. There we go. And same thing for mouse button up, except of course we change down to up. Very easy. We are almost done here. Now for the hardest one, and this is the actual text input. We want to be able to create a text box and then input text into it. So let's start by, let's go ahead and create ourselves a text box, and then we'll go from there. So let's go back to the gameplay screen. Now we're going to do pretty much the same thing we did with this test button. I'm actually going to copy this because I'm so lazy and put it right here. Now instead of a push button, it's going to be a combo box. Combo box allows you to input text into it. And we're going to static cast to a combo box here. Now instead of Tazerac look button, we're going to do Tazerac look combo box. Remember, if you're using a different scheme, you may not have this. Go check the data file. For the position, let's just change that to 0.2.2. And we can't call it test button because that will definitely cause a crash. So we're going to call it test combo box. And let's make sure the variable name is the same. Test combo box. There we go. Now we should have a combo box on the screen. And we should be able to actually click on it. And we also should see our mouse moving around, since we're, actually no, we haven't injected any inputs. We're almost able to, but we actually have to do that. We have to go to check input here, and we have to inject our input. So we're going to say im GUI on STL event, and we're going to pass an event there. So now we're injecting our input there, so we can run it. And we should be able to see our mouse moving around, and we should be able to actually click on things, and you should see a little animation whenever I mouse over the button and click. So as you can see, we have a mouse cursor that's following the mouse. We actually have two mouse cursors. And when I click here on the hello world, it'll do a little animation, and then when I click up here, it'll select, so we can actually begin typing stuff in. But when I type things, nothing actually happens because we haven't done the text input for SDL yet. And before we do the actual text input for SDL, there is one more event that I forgot to tell you about. If we go to GUI, we need to actually inject a time value. We need to tell CEGUI how much time has passed each frame so that it can actually do any kind of animation or anything like that that it needs. And to do that, we're going to have to make an update function. So what we're going to do is we're going to go back into our header file and add void update. And this update function is just going to be updating the time. Now if we don't call this update function, it shouldn't break, nothing bad should happen, but if there's anything in CEGUI that cares about the time, it's not going to work properly. So what we're going to do is we're going to need to call imContext inject time pulse. And this takes the time in seconds since the last update, or the last time you called inject time pulse. So what we're going to do is we're going to do pretty much what we usually do with the SDL get ticks when we made our FPS counter and all that. We're going to have an unsigned int elapsed. That's going to be the elapsed time. Alright, and then we're going to have, we need a last time variable in our GUI. So we're going to put here, we'll have unsigned int m last time, and we're going to start this out at 0. Now, what we can do is we can say if last time is equal to 0, that means it's the very first time this has been called, else we do update as normally. Now if last time is 0, then we're going to just say that elapsed is equal to 0, so 0 time has passed since we just began, and then we're going to say last time equals SDL get ticks, and that will get the time in milliseconds. Remember, ticks is milliseconds. And to do that, we're getting an error because we need to include something else. We're going to include SDL timer .h. There we go. Where are we? Oh, up. Right. Okay, now that should go away. Good. Now we need to get the next time. We're going to say unsigned int next time is going to be SDL get ticks. And now we can compute the elapsed time from that next time. So we can say elapsed equals next time minus m last time. And then we set m last time finally equals next time. And now to inject the time pulse, we just need to convert our unsigned int milliseconds into an integer, or an unsigned integer seconds, or sorry, into a floating point seconds. So we're going to cast elapsed to a float. We're going to say float elapsed, and we're going to divide by 1,000 milliseconds to convert to seconds. There, now we are injecting the time pulse, which isn't going to change anything in this tutorial, but it's important that we do that. Now finally, let's talk about text input. So if we want to actually input stuff into that combo box, we need to be able to handle Unicode. Now Unicode, if you're not familiar with it, the reason Unicode was invented is because all sorts of different computers had all sorts of different codes for their characters, for the keys on the keyboard. For instance, you may have different key codes for Hungarian characters or English characters or German characters and all that, and it was really a huge pain because there were all these different standards. Now Unicode came out so that there was just one standard where every single key had its very own unique value. And if you want to look up the actual Unicode format that we're using here is UTF-32, and I will put a link to UTF-32 in the description, but I'm not really going to teach you much about Unicode in this tutorial. I'm pretty much just going to show you how to get this working with the Unicode. It's really not too hard, and we can do that without learning too much about Unicode. So in SDL, oops, that's not what I wanted to do. In SDL 2.0, it's a little bit different. You'll notice in the link that I gave you, they actually have this out-of-date thing here. They have this inject char that uses this keysim.unicode. That does not work anymore with SDL 2.0. We have to do something different. So here we are in SDL text input. This is what we're going to be using. Now we're going to need a few things at the top. We can't declare variables inside this, so we're going to need to put our variable at the top, and we're going to have a CEGUI : UTF-32, and we'll call it code point. This is going to be our UTF-32 value for whatever text input SDL gave us, and SDL is going to give it to us in UTF-32, so we don't have to manually do some kind of crazy conversion. It's not too hard. Now with this, first thing we want to do is set that code point to 0, and then we need to look at event.text.text. Now if I go here, you'll see what it is. So it's a char, and this is the input text, and it's actually an array of chars of size 32. Now what this is it's basically a variable length Unicode string, and it's always going to be null terminated, so the last value in that string is going to be 0. Now if we type an ASCII value, like for instance the letter A, the ASCII value is going to fit between 0 and 256. The Unicode values for the ASCII table are the same as the ASCII values. So in that case, we're just going to be using a single char, and then there's going to be a null character, which is 0, after that. However, if we were to type some kind of crazy Unicode character in, it might use 2 or more. It's really just going to use however many chars as it needs bits, up to 32, but in our case, it can only use up to 4, since we only are using UTF-32. If there's any more than that, we're going to have a problem, but that shouldn't happen. Now let's go back to GUI, and let's actually do this. So what we need to do is do a for loop, and we're going to loop through those chars. We're going to say for int I equals 0, I is less than event.text.text, or sorry, not I is less than. We're going to say do this so long as event.text.text I is not equal to the null character. Now the null character is 0, so we could also put 0 here. It would work either way, but I like to put the null character because it's a little bit more explicit. And finally, we're going to do I++. So for everything that we're going to be able to type, if you're using an English keyboard, is going to just only use a single char, because it's going to be using the ASCII values. So we're only going to iterate through this one time. But if we were to be typing in crazy Unicode characters, this will handle it. Now what we need to do here is we need to do some bitwise stuff. So this code point right here, this UTF-32, it is an unsigned int, and what it is it's going to be the code value for our Unicode character, and we need to actually build it from this char array. And to do that, we're going to have to manually use bitwise operations as well as bit shifts. So I need to teach you about bit shifts because I haven't done that before. So I'm going to open up a notepad here. Now let's say we have a byte here. Now I really should have taught you this during our bitwise tutorials, but I didn't. Luckily, it's really, really easy. Let's say this is our byte, and let's say we have it set to 1, like that. So this is the integer 1. If we take that, if we take 1 and we left shift it 1, you'll notice this is the same operator that we use in cout. However, it's a different operator in this case. This is the bitwise left shift, or the left bit shift. What that's going to do is just going to take all of our bits and just shift them left. So instead of 0001 here, it's just going to be 010. That's all it is. If we had left shifted twice, then we would go 2 spots over with our 1 bit. That's all it does. It just shifts the whole thing over. And you can also shift to the right. If we were to shift 1 to the right by 1, it would be just 0 because we'd shift the 1 off the end. But you get how it works. It's really, really simple. And a little fun fact, anytime you left shift by 1, that's the same as multiplying your number by 2. And right shifting by 1 is dividing by 2. Compilers will actually optimize your divisions and multiplications by 2 or by powers of 2 by using bit shifts, which makes them a lot faster. It's kind of neat. So that's bit shifting, and the way we're going to use this is, let's say we have our UTF-32 value here. Right now I'm only going to use 2 chars, which is 16 bytes, just for simplicity. So here we have our code point. It's set to 0. Let's say the first letter is A, and I have no idea what the Unicode value or the ASCII value for A is. I forgot. I think it's like 97 or something like that. And I'm just going to put a bunch of 1s here. What we're going to do is we're going to want to store that A right here in the least significant bits. And then let's say they typed something much more complicated that used 2 chars. We're going to want to store the first char here and the second char here. And in order to store the second char here, we're just going to bit shift it to the left by 8 bits. Really, really simple. So let's go ahead and do that. Let's say code point. And we're going to use bitwise OR here. And you can actually use bitwise OR to set flags. Remember, to set values, just like we did in the bitwise operation tutorial. And we're going to OR it with event.text.texti left shifted by I times 8. So if it's the very first iteration, we're going to left shift it by 0, which does nothing. If it's the second iteration, we're going to left shift it by 8, which will put it in this byte. If it's the third iteration, we'll put it in this byte. See how that works? It's really, really simple. And we're just going to build this 32-bit value until we hit the null character, which in our case should happen pretty much immediately after the very first iteration. There we go. Now this is actually going to be a bug because this text right here is a char, and if you try to left shift a char by more than 8 bits, you're just going to shift it off the end. So we want to actually cast this to an unsigned int, or we'll just cast it to a UTF-32 before we shift it, just to make sure we're not truncating any bits or anything like that. And I'm going to surround this whole thing in parentheses just because I'm so paranoid about everything, even though it'll work without the parentheses. There we go. So now we have built our code point, and we can actually inject the code point. So we're going to say imContext inject char, and we're going to pass code point here. There we go, and that's all we have to do. So now we should be able to input text. Let's go ahead and run it in debug mode and see if we can get some text on the screen. And in the next tutorial, we are going to be actually doing events. Right now, we can input things and we can type stuff. Here we go. As you can see, it works. Hello world. However, if I click on this button, nothing's going to happen because we haven't hooked up any events to it. That's what we're going to be doing next. And then we might actually build some kind of user interface that makes sense. So I hope you liked watching this tutorial. I hope you learned a little bit about BitShift and Unicode and CEGUI and all that stuff. Hopefully CEGUI will put this video on their website or use what I've taught in this video to kind of update some of their documentation because, like I said, it's not really updated for SDL2. And if you didn't know, they actually did put the 2 previous videos on their website, so kudos to them. Thank you very much for doing that, guys. I do love your UI library, and so it makes me very happy that you did that. Alright guys, see you in the next video. Hey guys, real quick, I forgot to show you how to actually disable the default mouse cursor so we only see the CEGUI mouse cursor. Really easy, we just say STL show cursor, and 1 means show the cursor, 0 means don't show the cursor. So we're going to put a 0 here, and then when we actually run the game, we should no longer see our little default mouse cursor, we should only see the CEGUI mouse cursor on the screen, which In fact, it does work now, as you can see. Okay, thanks.